Hello, morning everyone. Today I am going to talk about the cooking stove. Traditional cooking stove is too much smoky and bad for the health problem. So I designed this improved cooking stove. So let's go from the start. I will show you all about this project, what I did and how I did it. Okay, let's go. This is our content total. Okay, let's go through the introduction, then other thing. Okay, let me go through that. Okay, stove is the combination of heat generation and that transferring to pot from where we got our food cooked. And we need our cooking stove to consume less fuel, save cooking time, provide the better environment in the kitchen. Okay, and especially I did this project in my bachelor, so it all about the Nepal condition. So in context of Nepal, around 75% people are still using wood or animal dung as a cooking material. Not the cooking material, but it's a raw material for burning. Okay. So 1.6 million people die each year because of this indoor pollution. So we need a better solution. Okay. So that is ICS, Improve Cooking Stove. So goal of this stove is to improve health, reduce environmental impact, increase energy efficiency in household. There are many plans which are carried out to distribute the different ICS like the old ICS, metallic, institutional ICS, okay, to familiarize the people with the improved cooking stove. And these are the different type of cooking stove that are used in Nepal. Okay, and what do you have in from and what are the problem of traditional cooking stuff? High heat loss, low efficiency, high smoke, high consumption, longer eating time because of incomplete combustion of wood. And these are the literature from where I got all the help. Okay, let's go from one to one. First is the increase in the secondary air inlet and number of holes increase the performance of cooking stove. Okay, and second so the keeping the gap between the pot and the mm, stove stand will help to get more oxygen and that lead to complete combustion. Okay, it shows that there is two process in combustion like the one surface combustion and gas combustion. So for the complete combustion process it need to be done. So this is our objective. We are going to design and fabricate. We did fabricated it practically and tested everything, and this is the process. After that we use SolidWorks for design. Okay, and different material for the construction, and we use different testing equipment. And this is the first thing that I got. Mm, I This project is totally dependent on this data. I got this from this source, so our cooking stove dimensions are little bit varied from this specification, and this is our final cooking stove. Okay, it is especially for 70 cm pot. Okay, which is the average for 4 to 5 to 6 member of family, and combustion chamber has 30 cm diameter and 28 cm height, as you can see, and total height of the stove is 50 cm. It's kind of lengthy, but okay. And we fabricated it, and we use 1 mm of thickness cast iron, and the total weight is 5.3. It kind of heavy, but okay, we can carry it one place to another place. And these are the different chambers of stove: combustion chamber, main inlet, okay, outer cylinder, grate, skirt, as you can see in the figure. Okay, these are fabricated as for the total design. As you can see from the different perspective, it's look good. And for the testing, we did cold status, hot status, simmering test. Based on this performance, time taken to boil 1.5, and we calculated all the performance parameters like the thermal performance, time taken to boil 1.5 liter of water, especially fuel consumption, burning rate, power. Okay, these are all formulas that are used for the performance calculation, and these are the equipment that we use to go carry out all the testing. And I got the results. It take around, in cold start it take around 14.33 minutes to boil 1.5 liter, and in hot phase 10.66. Okay, and I got the thermal efficiency 22 in cold phase, 32 on hot phase, 25 on simmering. And especially fuel consumption, burning rate, firepower. Okay, and these are all temperature, how this temperature increases with the time for different steps. And cold phases add little bit core because of the cold ignition, but hot phase is already hot, so it has a little bit straight. So for our conclusion, average efficiency of cooking stove is 27, which is very good. Okay, and I compare it with the other previous cooking stove which are installed in the Nepal, like Rupendehi. It has cold start in 19, only 19, hot start in 22. There is another stoves which are installed in other area. So our cooking stove is better than other. Okay, as you can see, there are different cooking stove from China which using the wood as only 23, which is lower than our. Especially, okay, I will talk later. So I compare all of them, but our cooking stove has a good quality. Okay, okay, and one of the most important thing is that different about our cooking stove is we use two inlet. Okay, as you can see, this is the main inlet. Okay, and we use these holes for the secondary inlet. Okay, and air goes from the offside. This is our main thing. We have holes in the inner side. Okay, and air goes from down air to directly into the combustion chamber. Okay, there is more inlet for air, which is main model. Okay, then thank you.